Hey there, pre-calc friends. Welcome back. This is going to be another day mostly focused on hyperbolas, but I do want us to start thinking about some patterns and characteristics between the three conics that we've been talking about. So, like one of the most obvious things I think to point out is that circles and ellipses both have addition signs in their between their terms in their equations. However, the hyperbola equation has a subtraction sign. And we can kind of see that flip-flop in the C equations. For ellipse, it's subtraction, and for hyperbolas, it's addition. So that's just one example, but we'll continue to kind of look for some of those today. Our first example today is getting us to think about how do I know based on an equation what type of conic it represents. So, maybe the easiest way is just to type it into Desmos and look at the graph. And so we can see that it is a hyperbola, a horizontal hyperbola based on the graph on Desmos. We also can tell that it's a hyperbola because of that subtraction between the terms, and that it's set equal to 1, right? So that's very uniquely hyperbola, okay? So let's go through and graph this one here. So it looks like my center is going to be -1, 3. So I'm going to put that center on my graph. And then it looks like my A is going to be 5. And because this is horizontal, that means I go out 5 horizontally from my center. So that gives me what? -6, 3. Ooh, wow. And 4, 3 for my major vertices of my hyperbola. And now I can see that my B is also 5, which is kind of interesting, right? We've never seen an ellipse that has the same A and B, and that's because in an ellipse, you can't have the same A and B. So you might think about why that is. If you look at the equation for an ellipse, if not for the ellipse, but for the C value, right? If A and B were the same, then I would get 0 for my C value. And you might also think about, if I'm vertically and horizontally stretching by the same factor, then does that make an ellipse? Does that make an oval? No, that would make a circle then. So that's why ellipses, you will never see the same A and B value, but in hyperbola land, that is A-okay, right? We're going to have quite a nice hyperbola here. Alrighty, so there you have it. So when I draw in my asymptotes, I'm going to make a rectangle here. But if you wanted to use your own slope here, this is actually a nice one because my slope ends up just being 1, right? Because my my A and B are both 5. So if I think rise over run, 5 divided by 5 would just give you a slope of 1. And then the negative would be a -1. So kind of a nice slope there. All right, so there are my asymptotes. I like the rectangle method, but good to think about slopes here. Let's draw in my hyperbola. All righty, here we go. There it is. All right, looks all right. Now let's solve for my foci, my C value. So I'm going to use that C squared equation equals 25 plus 25. So I get C to be the square root of 50. So let's type that in, get a decimal approximation. I get about 7.1. So it's going to be 7.1 coming from the center. So 5, 6, 7.1. So that gets me what? About 8.1? No, 6.1. 6.13. And then in the other direction, that's where I'm going to get a -8.1, comma 3. Okay, so those are my two foci, and just always, like I said, make sure that your foci for a hyperbola are outside of those major vertices, okay? So kind of think of them, maybe kind of like a pea in a bowl, because I always use green for my foci. Alrighty, so that's the hyperbola, a little review there. Hopefully you remember that. For example 2 today, we're going to kind of throw it back to an ellipse problem. So consider the picture at right. A truck full of calculators, oh my gosh, this is very important, is driving through a semi-elliptical tunnel, okay? So semi-elliptical just means like, think of a semicircle as half of a circle. A semi-elliptical just means it's half of a ellipse, okay? So looking at this then, I want to think about the tunnel, and then I'm actually going to draw in a coordinate plane there, okay? So basically, we want to ask ourselves, is the truck going to be able to make it through the tunnel, or is it going to kind of scrape its sides? So maybe you've kind of experienced this before. I know I have, like often driving into like parking ramps where you're like, oh gosh, it feels like my car is going to be like scrape the top of this tunnel here. So that's kind of what we're calculating. So to do that, we need an equation for our for the semi-elliptical tunnel, okay? So here I just kind of drew in a coordinate plane. So you can kind of think over here is quadrant 1, quadrant 2. So it looks like my center is going to be 0, 0. So you can think like this point would be 15, 0. This point over here would be negative 15, 0. And then this point up here would be 0, 12. Alrighty, so looking at this ellipse, my A is going to be 15, right? It's a horizontal ellipse. My B is going to be 12. So to make my equation, it would just be x squared plus y squared equals 1, right? An addition sign because this is an ellipse. The A, the horizontal, goes below my x, and the B, the vertical there, goes below my y squared. I guess we should solve for C, but actually we don't really need it. But just a little throwback, we will. So remember, the equation for an ellipse to find the C has a subtraction instead of an addition. So obviously we can use our equations on assessments, so you don't need to memorize that. But still good to just familiarize yourself with it. All right. So I get a C value of 9, so that would be my foci. So if you think about graphing that, again, those foci would be within my major endpoints, whereas a hyperbola, they're outside your major endpoints, okay? So now let's get to the good part. We want to know, is this truck full of calculators? Very important. Is it going to make it through the tunnel? So we are interested in those 2 points that I kind of outlined in blue there. So you can see that the truck, whoa, interesting. What just happened? Okay, you can kind of see that the truck is 5 feet out this way, and the truck is 11 feet tall. So what I'm going to do is, into my ellipse equation, I'm going to plug in 5 to the right of 0, 0, so x equals 5, and I'm going to figure out the height of what's the output, the height of the tunnel at that point. And if it's more than 11 feet, then the truck will be good to go. If it's equal to 11 or less than 11, then that truck is going to get stuck. All right, so let's plug in 5 for x. So 5 squared over 15 squared. So here's my equation. Now let's just use some algebra to solve for y. So I'm going to do 1 minus 5 squared divided by 15 squared, and I get about 0.89. So it's y squared over 12 squared equals 0.89. So in order to solve for, to get y by itself, I'm going to multiply both sides by 12 squared, right, to get that to cancel out. So 0.8, this thingy, times 12 squared gets me 128, okay? So I get y squared equals 128. So I'm going to square root both sides to get my y value. And if it's bigger than 11, then that means my truck will make it. Awesome. It is bigger than 11. So my 11-foot truck is going to be able to make it. Yes, beautiful. And I don't have to worry about like -5 right to the left of the truck because, because of the symmetry of my ellipse, you know what I mean? If it makes it on one side, it will make it on the other as well. All right. So I really like this problem. I think it's really interesting and it's relatable. I definitely had that feeling of like, oh my gosh, the top of my car is going to scrape this tunnel. It never happens, especially because I have a very small car. But sometimes you do see those signs of like, oh, if you have a car that's above this height, like don't come in here. So let me know if you can relate to that. All right. With that, we're going to finish up today with this example 3. All right, so notice that it's equal to 36. So I might be thinking, oh, maybe this is a circle with radius 6, but then I see the subtraction. So that subtraction makes me think, I think this has to be a hyperbola. So if it is a hyperbola, I need to set this equal to 1. All right, so in order to get 1 to be on the right-hand side, I'm going to divide everything by 36, okay? And then we start to see some things happen, right? Because what's 4 divided by 36? Can't I reduce that fraction to be 1/9? And 9 over 36, isn't that just 1/4, right? And just as a reminder, if you're like, Shinners, I don't know fractions, remember the trick, right? Math and then frac, and it will reduce that fraction for you, okay? So there's my hyperbola. Now I see it in clear form. Oops, dropped my pen. What type of conic is this? This is going to be a horizontal hyperbola, right? Because that x comes first. This is going to be horizontal hyperbola. Center is 0, 0. Center is 0, 0. My A is 3, and so this is horizontal, so I'm going to go out 3 and -3 for my major vertices. Oh my gosh, people are talking to me. Just ignore. All right, my B is 2, so I'm going to go up 2 and down 2. There we go. For my minors, here, let's see if I can just, there we go. All right. So there's my majors, there's my minors. I'm going to make my rectangle now to get my asymptotes going here. Whoa. Alrighty. Here we go. Just going to erase that little guy there. Alrighty, so now let's get my diagonals. This would be, if you are using your the slope, it would be like up 2 over 3 here. Oh gosh. Shapes, line. All right, here we go. So here's one asymptote, positive slope. Here's the other asymptote, negative slope. All righty, so let's draw in my horizontal hyperbola here. Here we go. Here we go. All righty, there it is. And last but not least, let's solve for my foci. So c squared would equal 9 plus 4. So that would give me root 13. And that is about 3.6 for my C value. So that means I'm just going to go out 3.6 and then to the left 3.6. This is a hyperbola. So now my foci are on the outside of my endpoints there. So that would be 3.6 and negative 3.6. Okay. And so that is how that would work for this one. So if you see something and it's not set equal to 1, that doesn't automatically make it a circle, right? So make sure you're checking for that addition or subtraction sign. Awesome. All right. Let me know if you have any questions, folks. Start the practice here, and Gibbon will make a video walking you through that if you've got any questions. All right. You might want to bookmark this page or something because these equations are probably pretty useful as you work through your problems. All right.